In this video, I'm going to do something a little bit different. I am actually going to introduce you to one of the students that I have been tutoring for
My
free.
name is Destiny. I am 14 years old. I'm a freshman.
Now, I don't just take on any student for free tutoring. I wanted to take on students that had a goal, that had a need, not just help with math, but wanted to accomplish something by working with myself.
Math is something that I see me having a challenge in. Challenges I have all high grades in my other classes. Like I have hundreds in my other classes, and math is the only
So math is
one.
the one.
Yeah, and it's just making me mad. Like, why is that the only class that I'm like have a like? Well, I think it's a low grade in my opinion. I just know I want to be better in that subject.
So Destiny went to brianmclogan.com/tutoring, which you can too, and she put in an application, which you can too if you want to work with me for free. Now, that's one of the big things that I really do miss about teaching is being able to work with students one-on-one. So I got really excited when I had the opportunity to work with Destiny. She reached out to me saying that
Right now I have a 70 in math,
okay.
and so I want to get like to like a 90 or like 100.
So I said, you know what? Let's take on the student and let's go ahead and help her get a B, because that's what I want to be able to do as a private tutor. And the reason why I offer my tutoring services for free is because I want to be able to document the journey of Destiny and to inspire those of you out there that are struggling with your math at times to realize that you can overcome and succeed in math. There's always going to be times that we're going to struggle, and sometimes acknowledging them is not very fun. So I'm really happy that Destiny reached out to me, and I'm really excited to share with you kind of her story and journey as we work through getting her grade up to a B.
Like, to kind of give you a little backstory, like on me, like I struggled, I made mistakes all the time as a student. So one of my things that I always try to do is like when you're taking a test, you got to think through the problems, but you also don't want to like let one problem take like 20 minutes, right? It's like, look at a problem. If you don't know how to do, what I always tell students or what I learn is like, just skip it. Like if you're struggling with one that's like, or it seems really hard, like move on, come back to it later. And let's say you have like 20 minutes at the end of the test. Well, now go back to those like really, really difficult problems, and really try to address them and really try to like spend more time on them. And there's a couple reasons why that works. One, your brain's kind of a little bit more primed. Once you've kind of done problems, you know how to do, and you kind of build that confidence, your kind of brain remembers things. It's kind of kind of like a moving train, right? It's got momentum going. So then if you can hit those problems at the end, not saying you're automatically going to always remember them, but like, I feel like you kind of got a little bit of momentum. Like you've just gotten to that point. Whereas like, there's nothing worse than like starting a test and spending 15 minutes on one problem, being like, I still know what to do. And now my brain hurts and I'm like, now frustrated, right? And like stressed because I just wasted 15 minutes and I don't like, on this really hard problem. And then the other thing is like, too, yeah, if you can go back through a test to like, check for like any mistakes, like I think I would always find mistakes when I went back through my test. Like I was just constantly make mistakes. All right. So since this is like our first meeting, I don't really know what you don't know, where you struggle. So first of all, whenever we do tutoring, like, I don't want you to feel like I'm doing like a got you or like trying to make you feel stupid or whatever else. Like a lot of times I will ask questions just to kind of see where you understand, what you don't understand, because sometimes that it's not so much like I want to show you like make you feel like you don't understand something, but like it helps me understand what you know, what you don't know. So therefore I can adjust the instruction, right? Sometimes I might go deep on something. Sometimes I might just like skip over things, right? So, but for at least right now, like, I mean, if, in general on this problem, like what, based on the directions, like what do you kind of like don't feel comfortable with or don't feel confident on?
Okay, so I know you're supposed to like box. Well, she says box the different signs, same number, like just eliminate it a little bit. And the part I'm confused on is when you take the bottom number, you pick one number at the end. And
are you talking about this equation right here, the 6y minus 3x?
yes, that one. So you take that one, and then whatever you get for you. Okay, so first you solve it, and then whatever you get for that, you plug it to the y. So the answer would be y equals to like 1, right? And then you put 6 times 6 parentheses 1, and you get like 6y. And I don't know what to do from then.
All right, so let's work through this step by step then, and maybe I can like help you out. So do you feel comfortable with the y, or do you want me to kind of go through it and you can maybe stop me?
Okay, you can go through it.
Okay, so I'll just kind of go through solving for y, and then like if something's not making sense or you have like a follow-up question, let me know. So the main thing is like this is in the form of y equals mx plus b, right? And that's typically when we want to, and actually real quick before I get started, like the direction says to graph correctly, like to graph the system. Yeah. Okay. So we want it in this format, because if you have it in this format, what we have is like the slope, right? And this is going to be the y-intercept. So it's just really nice to be able to solve something when it's in this form. And especially when we want to solve a system of equations, we want to find that intersection point. There is another way you could solve this using the intercept method, or to graph this using the intercept method, but I wouldn't recommend it for a solving system of equations. So our main goal here is to solve for y. That's the first thing we want to do. So sometimes what I like to do when I'm solving for y is just like put a circle around it. Okay. And the reason why I put a circle around it is because you want to be able to identify and say like, hey, what is happening to this y that we need to undo, right? Because I want the y to be all by itself. So you can see the y is being multiplied by 6 and being subtracted, or 3x is being subtracted from it. Right. So hopefully, using your inverse operations, we always undo addition and subtraction first. So that's why I'm going to add a 3x to both sides, right? Using the addition property of equality.
Okay.
And therefore, then I'll be left with a 6y equals. Now, you could write it like this, but a lot of times in math, we just kind of say we want the variable to be written first. So we can rewrite it like this. And again, it doesn't really matter, if it's 6 plus 3x or 3x plus 6. Typically, we just kind of skip to this step, though. Are you good with me here?
Isn't it different signs subtract, or?
I don't know what your teacher is saying different signs subtract, or what your teacher was doing.
Because 6y, so it's 6y minus negative 3x equals to 6, and it's the part where it's like plus 3x. Don't we cancel that out?
Yeah,
not subtract, but cancel. I'm just saying cancel.
Yeah, it adds the 0. So negative 3x plus 3x. So technically, what we have here is negative 3x plus 3x is going to be a plus a 0x.
Yeah.
Right? But 0 times x is 0, and then 6y plus 0 is just 6y. So that's why I just wrote it like that. So again, like we don't really write that stuff just because, once you add the inverse to it, like negative 3 plus 3x, like that's just going to go to 0. So we just write it down to 6y. But you can show that step. It's just an extra. It's kind of like me showing 6 plus 3x. We usually don't show it. We just kind of rewrite it as a 3x plus 6.
Yeah. Okay.
And so now we look at this and, I'll just circle the y again and say, all right, what's happening to this y? Well, again, the y is being multiplied by 6. So we have to undo multiplying by 6, right? So to undo subtracting, we added. So to undo multiplication, we are going to divide. And notice how I put the division symbol across everything on this right-hand side, because the 6 has to divide into both of these terms. So 6 divided by 6, right? Again, you don't need to show this, but 6 divided by 6 is a 1.
Y.
Right. So it's a 1 times y, right? Which is really just y, but we'll take this one slow. And then over here, you got to make sure you divide the 6 into both terms. So this is a 3x plus 6, and I'm just going to make sure you distribute this. This is just really important. A lot of students will only divide the 6 into the 6.
Okay.
So you got to make sure you divide the 6 into both of these terms.
Okay.
All right. And then what you have is a final answer of y equals, now this 3 over 6, 6 doesn't divide to 3, but you can reduce that to a 1/2. And let me know if you need help or explain on that. And then over here, 6 over 6 is equal to a 1. So just let me know if you want me to further explain anything on that.
No, I'm good. Okay, so for the other part, so because we have y equals to 1/2 x minus 1, right? So what do we do after that?
Okay, so now we have two equations, right? So we have equation number 1 and we have equation number 2. So when we're graphing a system of equations, what we're looking for is we're looking for the point of intersection. We're looking for the x and the y coordinate that these two graphs are going to meet. And the values for x and y where these two equations meet is what we call the solution to this system. And those values are going to make both of these equations true if they intersect. So what we need to do is, once you have them both in slope intercept form, and sometimes a lot of problems start with them in slope intercept form, so you wouldn't even have to do all this mess. Right. And this was kind of like a lot of work. A lot of times problems just start right here and they're like, solve the systems. You're like, okay, cool. So now we need to graph these system equations. And are you familiar with graphing in slope intercept form?
Yeah, I am.
Okay. So remember, the first thing we want to do is always identify the y-intercept. So here is our y-axis. Here's our x-axis. So the y-intercept is basically the graph where it's going to cross the y-axis. So here it's at -1, right? So it's because it's plus b. So this is really could be also rewritten 1fx plus a -1. So our y-intercept is -1. So I'm just going to make a point here and say, all right, well, here's -1.
Okay.
Okay. And then now we need to follow the slope, which is going to take us to the next point. So the slope is our coefficient of x. And remember, you can think of slope as like the rise over run. You could be more mathematical and say the change in y over the change of x, blah, blah, blah. But typically, you know, the top number, the numerator, is saying to go to your next point, you can go that number. So it's 1. So go up 1. And then the bottom number is 2. That's going to tell you how far to go left or right. Well, since it's a positive 2, we're going to go 2 units to the right.
And that's for the rise over run, right?
Yep.
Okay, so with the the rise over run, it start with the top number, so you go up 1 and then 2 to the right.
Correct.
Okay.
Now, I don't want to get ahead of myself, but just remember that 1 over 2 is the same thing as -1 over -2, right?
Mm-hmm.
Okay, because negative divided by negative is still positive, right?
Okay, yeah.
So technically, you could also go down 1 and to the left 2. Do you see how that point, though, still lies on the line?
Yeah.
Okay, so up and to the right or down and to the left doesn't really matter. You could do either one of those, all right? It gets confusing because students are like, why can't you just do the same thing? Well, sometimes we do get problems where we want to go to the right, and sometimes we get problems where we want to go to the left. It's kind of hard to explain. Like, we could do some example. I could do some, like, pick some examples so you can see why or how we do that. But I'll just leave it in this case of you. Hopefully you recognize you can go in both directions.
Yeah.
Okay.
I think, I was watching, like, didn't you like post this on YouTube like a while back ago? Well, like
I mean, I'm definitely have like a ton of videos on this.
Yeah, and I was confused on like why like my teachers and like you did like with the part where you go like to the left, like what you just did.
All right. Well, let me go and finish this problem, and then I'll give you an explanation of why you might want to go to the left or to the right.
Okay.
All right. Okay. So now the next problem, so the next one. So that was equation number 1, right?
Mm-hmm.
So equation number 1. All right. So now let's go and do equation number 2. So equation number 2 is now the y-intercept here is +1. So now I got to go up 1. Now in this example, it doesn't really matter if you want to go to the right or to the left, like, because notice how the slopes are exactly the same, right? They're both 1/2. So you're going to go up 1 and then over 2. So these are what we call parallel lines.
Oh, okay.
Right? Remember the train tracks?
Yeah.
Like kind of idea, like parallel lines, they just never touch, right? They're kind of like train tracks, like they never intersect. So that's a problem because remember our solution to the system was the intersection, right? That's why we want to find where they intersect. Well, we have an issue here because they don't intersect.
Oh, that's why you get no solution.
That's why this is no solution.
Oh,
right?
Okay.
So a quick little way what you could do this problem, again, like obviously doing your homework, you're going to need to like show your work and stuff, but like a quick way for you to understand this is like whenever you see two equations that have the exact same slope, there's no solution because they're never going to intersect. Just a quick little tidbit. And I'll send this document over to you as well.
Okay.
So you have it, you know, stuff like that. But let me just go and add on to this one last thing because I did not segue enough time for us in there, but I can answer maybe if you have like another tidbit question from on there. But let me show you something real quick on this, and then maybe if you have like another small follow-up question, I can go through. Let's pretend you have the equation y equals a 1/2 x minus 1, right? And then let's pretend your other equation looks like this, right? So let's pretend you graph this red problem first, right? And again, remember, we're looking for the intersection point. So, and let's say I'm like, all right, graph y equals 1/2 x minus 1. Do you want to go up and to the right? Like that's not going to help you. Wouldn't you agree?
Yeah.
Like you want to find where they intersect. That's why you'd want to go to the left. So instead of saying, oh, it's up 1 over 2, you want to say, I want to go down 1 to the left 2, down 1 to the left 2. Oh, that's where they intersect, right? That's the point. -2. What -2 is the answer? Does that kind of make a little sense?
Yeah.
Whereas
Wait,
here,
you said down 1 and up 2?
no. Down 1, left 2.
Oh, okay.
Right? Because remember, rise is like up or down. So you're either going up or down. If it's positive, you go up. If it's negative, you go down. And then run is left or right. So if it's positive, you go right. If it's negative, you go left.
Okay.
But let me just give you like one more example here. Just like another thing. Let's say you're graphing, again, another system. But now in this one, again, I'm just going to make up another equation, +1. So down 1. Oh, what am I doing? I'm an idiot. That's not supposed to be negative. Sorry. This one's going to be negative though. Let's say I had this y equals a -1/2 x plus 1. So that graph looks like this. So let's say you have this graph, and then you're like, oh, well, here's my second equation. Looks like this, y equals a 1/2 x minus 1, right? So you're like, all right, I'm going to go down 1. Now here, do you want to go down and to the left too? No, right?
No.
Remember, when you're trying to solve a system, you want to like find the intersection point. So in this case, you want to go up and to the right. So you want to do the positive 1/2, right? You don't want to go down and to the left. Does that kind of make a little sense?
Yes,
It
because
doesn't happen a lot. I mean, it is something very specific, but like that's the reason why I just wanted to tell you when you're doing this problem, like you can go up and to the right or down and to the left, right? Because sometimes there are problems from your y-intercept, you want to go left, right? Sometimes there are problems from your y-intercept, you have to go right. So that's why I just wanted to like just throw it out there for you, just so you know. But is there anything else I can get you over the hump here with anything you're kind of working on until like our next session, which we can, set up for next week?
and also radicals. Oh my God, radicals. I'm not really. I know how to like with the numbers and stuff. I'm not really too good at it.
Okay. So is there anything hanging you up, or is there any like a problem you're like, oh my God, if you could just do this one problem or explain this real quick, this would at least maybe help me out for till tomorrow or whatever may be the case. Like, I know you don't have a test coming up tomorrow, so that's good. But
no. We have a quiz, but not a test though. Like,
is there anything just hanging you up, or I would just want to leave? I mean, like I said, I can add on anything on here, like the graphing, or if they're just, I don't know, anything else that.
Wait, because I'm trying to make sure I get everything. I don't want to. Oh yes. Oh my God. Oh yes. Okay. B equals to 1/3 pi r square h.
Okay. And what are you solving for?
We're solving for r.
So remember what I did on this first. Remember what I did up here. It's the same idea. Okay. What I like to do is find the variable you're solving for and circle it. Okay. Now, what you can do here is you have to identify everything that's happening to the variable. So we can see, all right, what is the h doing? Well, it's multiplying to it, right? What is I doing to it? It's multiplying. Right. What is the 1/3 doing? It's multiplying. So basically you have 3 things that are multiplying all by itself, right? Mm-hmm. Now, before I move on to the next thing, wouldn't you agree that 2 times 3 times 4 is equal to 4 times 3 times 2?
Yes.
So it really does not matter what the order is, right?
Mm-hmm.
When you're doing multiplication, just like addition, the order doesn't matter. Mm-hmm. So what I would do for this problem is I would actually rearrange this. So therefore my variable is at the very end. So I'd rearrange this as 1/3 pi h r squared.
Okay.
Okay. Because one thing that students will get in trouble with is they'll try to do one operation at a time, kind of like what I did up here. You know how I undid addition first, and then I undid division, right? So some students might get in trouble with and say, oh, well, I'm going to undo h and undo, I'm going to divide by h on both sides and then divide by pi. Well, if you're doing each of those like at times, sometimes it might get a little confusing. So what you can do though is divide them all at the same time. So to undo multiplying by 1/3, you divide by 1/3. To undo multiplying by pi, you divide by pi. To undo multiplying by h, you divide by h. Does that make sense?
So it's like is it like the number close to it, or what doesn't matter which number you're undoing?
Well, yeah, I mean you're solving for r.
Mm-hmm.
Right now, r is squared, but right now I want to undo multiplication.
Okay. I get it.
Okay. So, and so now the problem with the thing that gets confusing a lot of times with literal equations too is like there's no numbers, right? Mm-hmm. Like I always, it's always kind of funny because like, I mean, you could probably agree. Like a lot of people were like, I used to like math until like letters came involved, right?
Yeah.
But then like, we get to these and like students like, just give me numbers. Well, guess what? Sometimes you can just use numbers. Like again, like do the same thing. Like divide by, if you had this like over here, like, I don't know, 5 equals 4 times 3 times 2, right? Well, then, all right, divide by 4 times 3, right? You can do that on both sides, right? Now here you're going to get numbers, but here you can't really do anything. Now there is something that we can simplify this a little bit further to, because a couple things I want you to know. Like if I took the number 5 and I divided it by 1/2, okay, that is the same thing as multiplying by what we call multiplying by the reciprocal. All right.
Mhm.
5 divided by 1/2 is actually going to be 10. And let me show you why. Because here, I don't want fractions in the denominator. So to get rid of my fraction in the denominator, I can multiply by 2/1, which you do over top over here. So 5 times 2, when you multiply fractions, right? You multiply straight across. 5 times 2, which is going to be a 10. 1 times 1 is 1. And then what comes over here? This is 2/2. Well, what's 2/2? That's 10/1/1, which is just 10. Okay. So again, going to my point, instead of dividing by 1/2, you can just multiply by 3. So another way you would probably have this written, or you'd see it written on your answer sheet, would look like this. Okay. So instead of dividing by 1/3, it's actually really the same thing as multiplying by 3, which I showed over here.
Okay.
All right. And then the last thing we need to do is, again, what I'm doing is I'm using the reverse order of operations, right? You always undo addition and subtraction first.
Mm-hmm.
Always do that first. But there was no addition or subtraction. That's why we went to it. Then you undo multiplication and division, which we had multiplication. So we undid it. We just did it at the same time, right? Instead of dividing by 1/3, I decided to show it as multiplicating by the reciprocal, right? And the reciprocal of 1/3 is 3/1. Now we need to undo our powers. So how do you undo the r squared?
Oh, the R, don't you take the 2? No. You wait.
Well, if it was multiplied by 2, you divide by 2. So if it's raised to the second power, you're going to
divide it.
No, dividing is the inverse operation of multiplying.
Okay.
So it's the one thing you hate. The radical.
Oh my God, radical.
You gotta take the square root of both sides. Now, again, thankfully, you actually don't need to can't do anything more here, right? This is actually going to be it. 3b over a pi h equals r. And I'm pretty sure that's just how you would leave the answer in that case. Or you'd rate it like this. R is equal to square root of 3b over pi h. Okay. So what I would recommend for you is just to do that circling, like circle the variable trying to solve for, and then just undo the operations that are happening to it, right? Undo addition and subtraction first, undo multiplication and division next, undo the powers third, and then undo parentheses would be the next one if you have anything from there.
So that was our first session with Destiny, and I had an absolute blast working with her. It was a really fun time getting to know somebody that has only knows me through videos, right? I didn't know Destiny at all before the session. There was a little awkwardness up front, just kind of getting the technology all set up and just kind of getting to know each other. But I really felt natural, working with Destiny. She was very easy to, work with, and she was very helpful with, providing me with information she needed help on. So I'm definitely excited to set up my next appointment with Destiny so we can kind of continue to grow, because she has that test coming up and we have to go and get that grade up. One of the key takeaways I want you to take from this is when you have a test coming up, identify that date, right? And think about what are the things that you need to do to prepare every single day until that test date. Don't wait until the night before, right? Don't wait until a week to go ahead and randomly find a tutor, or hope that I have availability on my schedule, right? Don't do that. Destiny reached out to me a couple weeks prior to this. That's why we were able to get this session in on time.